staying at home. We're doing something a little bit different today. We are going to show you some activities that you can do outside, but I'm recording it from the inside because I want to make sure I get all the information. So we'll be showing some graphics to you and showing you exactly what's going on with these earth caches. Earth caches are an activity that you can do in your community. We have some set up around Edwardsville campus that we want to share with you today. We're going to be talking today about earth caching, but I want to start off by talking about the geology of Illinois, specifically Southern Illinois, where SIUE is located and where a lot of you might be watching from. The geology of Illinois can be summed up in three major topics: limestone, coal deposits, and glacial features. Understanding all three of these things will really help you understand all of what's going on geologically in Southern Illinois. It's also necessary to look into geologic time, which is one of the activities we put up this week. Geologic time covers an enormous span of time in millions and billions of years. The timeline over to the left of this screen shows some of what's going on in geologic time, some of the major events as they relate to Illinois. This is from the Illinois State Geologic Survey, and it covers a lot of the major milestones from the Mississippian period, when there's a tropical ocean covering the state and a lot of deposits of plant life and other things that got buried. The Pennsylvanian period is just after that, and that was when the seas had retreated a little bit. You got a lot of coastal swamp areas that led to some of the coal deposits, as we'll see. There's not a lot from the time of the dinosaurs, the Mesozoic period, but the Quaternary period, the most recent from the Ice Ages, is where we get all of our glaciated. Limestone is formed in deep ocean, and it comes from the plankton that float around the ocean. When they die, they're no longer able to keep themselves floating up, and they will sift to the bottom of the ocean and kind of pile up like snowdrifts. While Illinois was covered with oceans, there was a lot of limestone forming. Big drifts of plankton forming, mixed in with some mud and things, but it was really in the deep ocean and not near the coast most of the time. There are a lot of different types of limestone. This map shows them mapped again by the State Geologic Survey. It shows a lot of different types of limestone. Some of it has more flint that you can sort of use to make a spark, and some of it has less. Some of it might have some shells in it. So that's all those different colors, but all of that really is limestone. If you dig through the soil a little bit, when you hit rock, it'll be that limestone coming from plankton. Now, following that, the oceans retreated a little bit, and instead of a deep ocean, it was sort of a coastal area, much like Florida or other parts of the Gulf Coast today. There were some swamps along the coast, and those swamps had trees and other things that lived and died there. When the plant life fell over and fell into the water, if you've been to a swamp, you know the water there is sort of brackish and doesn't have a lot of scum or swamp weeds or anything growing in it. This is an anaerobic environment, and that means that things can't be decomposed the way they could if they fell over in the middle of a field or into another sort of lake or body of water. That means instead of being broken down, the trees there were compressed. They're piled over with mud, they were buried and got squeezed into some of the same material, the carbon that we can burn when we make campfires, but more efficient. And that's where we get coal from. This map here shows green areas where there are Pennsylvanian aged rocks. If you remember the limestone, some of this is sort of mixed in with limestone areas too, but the green area is where you can find rocks of the right age, and those colored dots in there show all of the different coal deposits in the state. Now, as I said, after these periods, the Pennsylvanian and the Mississippian, which in other parts of the world is called the Carboniferous period, these deposits are very, very old, from some of the first times when there were animals and plants colonizing the land. Then, of course, there's the famous age of the dinosaurs, but we don't really have any rocks from that period. It's not that there were no dinosaurs here, that somehow Illinois didn't exist during the time of the dinosaurs. We just don't have anything that's preserved. No rocks really got formed, so we don't have too many fossils or anything to rely on. It's not that there are none, just doesn't make up a big part of the geology in the state. Instead, we can skip ahead to the Ice Age, where we start getting glacial deposits. Now, this map, again from the Geologic Survey, shows all the different Quaternary Age rocks that you can find here. The pinks and yellows and oranges show some of the rocks that formed from sediment in lakes and streams and that sort of thing. The green, which is more up by Chicago in northern Illinois, shows some of the areas where glaciers actually sat. Glaciers work like huge bulldozers. They slide along and they push dirt ahead of them into big piles of dirt called moraines. Some of the darker green areas you can see are sort of imagine a glacier pushing along like a bulldozer and making a pile of dirt that's long like that. And those moraines form some of the rocks up in northern Illinois, but also while the glaciers were around and they were melting during the summertime a little bit, they would wash down and dump a lot of dirt and other things in rivers and lakes in southern Illinois. That's where we see the yellows and oranges and pinks. That dirt then formed into sedimentary rocks down here. So even where we didn't have glaciers actively going, like in Madison and St. Clair County here in the East St. Louis area, we still have glacial deposits from those glaciers. It's just not deposits that were put there by the glaciers, but rather that washed out from the glaciers. All that ground up dirt is what makes for the great farmland that we have in Illinois. And so it's really good that we had those glaciers and lets us grow a lot of crops. Now, I'm going to introduce the idea of earth caching and how that relates to all of this. Earth caching is a lot like geocaching, which might be more familiar to some of the viewers here. It's an informal learning experience. It's intended for a general audience. It highlights geologically significant sites. And so in geocaching, often you follow directions to a specific site. When you get there, there's sort of a treasure there. Some toys that you can trade out, a logbook to write your name in, that sort of thing. With earth caching, instead you arrive and there's something that's geologically interesting or a lesson to learn, something to find out about, something to see in your backyard. It's very popular. There are a lot of people doing it around the world. It's been around since 2004, and we wanted to set up some in around the SIUE campus. Earth caching has you go and look at a site and then answer some questions to sort of learn about what that site's about and what might be going on. Usually they're not too hard, but you can send them in afterwards. It's field-based learning. It's a really good way to get an authentic, relevant experience doing science and get an idea of the spatial area where you live in and what might be going on. Some example of formal versus informal learning. This is something that K-12 teachers probably would be very interested in, and we at the STEM Center are happy to talk about how you might do some informal learning. But parents also know that this is a great way to keep students active and do it in a fun way that supplements their learning in school. Earth caching relies on the Global Positioning System, or GPS. This is a system of satellites that is made up of a space segment, a control segment, and a user segment. The space segment follows these satellites as they orbit the Earth, and they keep track of covering the entire surface of the planet with several satellites at a time. The control segment is what goes on the planet. It's made up of control stations, antennas, monitoring stations, and between all of these things, they're spread throughout the planet and can maintain GPS in all the different areas. The user segment is your unit down here. This could be your phone, could be a dedicated GPS unit, could be your car. So many things today use GPS. And they rely on triangulating their position. They will get a signal from the satellite and they will connect to a control segment that tells them where the satellite is. If they get one signal, depending on the time it takes for the signal to bounce back off the satellite, they know how far away they are from that satellite. But that could be anywhere in this circle. If you add in a second satellite, now you've narrowed down to 2 points. It needs to be on both those circles, and there's only 2 parts where those circles intersect. A third satellite will let you narrow this down to a single point where all 3 of those circles meet. And you can triangulate in this way to show you exactly where you are on the planet. I hope you learned everything you need for earth caching today and that you enjoy some time outside and maybe you'll try out some earth caches. You can find ours at our website, siuestemcenter.org. We'll put the link to them in the video description and also should be appearing right below me now. I hope you enjoyed our video this week and that you'll join us again in the future for another STEM at Home.